Hi, everyone. Thanks for this. Some really wonderful conversation so far, and I'm really happy to be here talking about failure. I think it's really a great idea to embrace failure and to talk about it publicly. So yeah, when I heard about it, I really wanted to speak and kind of share my thoughts, add to the mix. So can I get on to the next slide? Yeah, so a little bit of background about me. So I'm a data scientist, as Fiona said. So I'm based in the ICB of Bristol, North Somerset, South Gloss, and I'm a kind of got maths and stats background. So my degree is in mathematics. I'm in a team of 4 data scientists, and there are roughly 20 data people who I sit with as well and work with. I'm not going to talk about the specifics of this, as we're going to stay high level. But if you're interested in the model that I'm talking about, so it's a population forecasting model. So we're forecasting, projecting into the future at quite a long term, so at kind of 15 to 20 years. And what we're doing is doing it at both age and health state level. So this is useful in resource planning. And I've written a blog post about this and spoken about this elsewhere if you're interested. And I'm very happy to receive emails and talk about the model itself. So that was the original model, and it seemed to work. It seemed to go okay. And I was thinking about this in context of failure, and does the model fail? So obviously, it's been really interesting hearing Chris and Fraser in discussion about kind of what is failure and the loadedness of that word. There are these different phrases that I find quite helpful. So, it's difficult to make predictions, especially about the future. You're never going to make good predictions about the future. And then this bottom one I quite like. A map is not the territory it represents, but if correct, has a similar structure to the territory, which accounts for its usefulness. That's a precursor to the famous George Box quote that is, all models are wrong, but some are useful. It's kind of the same thing, but I really like the framing. And obviously, maps are really, really useful. We use maps all the time, but they aren't completely accurate and precise. They're not the same thing. They're a representation. So they're wrong in that sense. That doesn't mean they're failures as such. But in kind of that context, I was thinking, well, what does it mean for the model to be a failure? We know that my projections aren't going to be exactly right, but that's based on lots of things. And then so I thought to kind of break it down a little bit. There's not just these 2 types of failing, but these two definitely exist in the modeling framework. So the first thing, when you build a model, you make a load of assumptions. I'm going to have lots and lots of different things that I assume to then make this simplification of the real world that is my model, my data science model. So it's a failure to make a modeling approach or assumption that's not appropriate to the question that's being asked. So that's definitely a kind of failure. The model will fail in that sense because it won't be able to do the task you ask of it. And the second thing is my code doing what I want it to? I've made all these assumptions, I've designed my model. Actually, have I made a mistake in the coding, or is the code doing something different? And they're 2 quite different types of failure, I think. So I've got 2 examples of some failures along this process. So originally the model was in discrete time, so I won't get too technical, but basically what that meant is we were doing things in steps. So I had this approach that was step-based, so 1 year at a time, step through, and that's like the dots on this chart, very regular, going through projecting into years into the future, 1 year at a time. That's how we saw the data. That's how the ONS published population projections. It kind of made sense. That's how our GP data comes in, GP record data. But continuous time is more realistic. Time feels continuous as we exist in it. There are frameworks for that. And so I had this bright idea that maybe the model would be better if we frame it as a continuous time problem, not a discrete time problem. And I spent some time doing it. And it didn't work. It looked wrong. Something was weird. We really didn't understand what it was. And the recoding that I'd done of this model was giving different options, and I couldn't work out what happened. It turned out that in this case, it was a failure of the first form, as in the assumptions were wrong. The assumptions weren't consistent across the modeling framework. So to get a little bit technical, I had individual people or patients moving between health states and age states. And that could happen continuously with some randomness alongside this thing called a Markov process. But basically, the thing that was making this all fall down was that I was trying to track their age as a state within this process, which doesn't work because your age year is not something that moves around continuously with any sense of randomness. It's very, very precise. So very, very precise and discrete. So I basically clashed 2 different assumptions together without realizing. What did I learn when I learned that this mistake had happened and that the reason why the continuous time didn't work? A lot of it was actually about kind of me personally. So I realized I had this thought in myself that was like, something's gone wrong. That means I'm not the best. So that means that I'm the worst and I'm worthless and it's all rubbish. And it's really interesting how obviously stupid and non-logical that thought process is. But even knowing that doesn't mean that it's not going to happen. And that's a kind of natural thing for me to go through. Some other things I learned, so I didn't know where the answer was or where it will come from. And it turned out that there were quite a few weeks over the summer that I spent on this change that turned out to not be appropriate. That doesn't mean that it's like it was a failure before it started. It doesn't mean that that's necessarily bad. Taking a break from the work was actually really helpful. Working on a different project, taking a small holiday, those things actually helped me get that distance from the project. Talking with other people was really, really helpful, so that it wasn't it kept this away from it being a personal failing as opposed to working on the project itself. And also being an expert, working on subject matter, trying to understand things better is always going to be helpful, even if it's not helpful with this specific problem. So that was my first failure. It wasn't my first failure. That was the first failure that we're going to talk about here. The second one as well, so stochastic or deterministic. Basically, there were some different models. They should have been exactly the same, just framed in different things that you can do in data science terms, either deterministically, which means it's going to be exactly the same every time, or stochastic with some randomness in. And these were the plots, and I thought, yeah, that looks great. Actually, it didn't look great. We can see in the top left, the two lines are doing something slightly different, and I had no idea what was happening. I knew that it was a failure, something was going wrong, and I couldn't work out where. And I'm aware that we're getting close to time with things kind of backing up. But basically, this was the second time of failure. My code wasn't doing what I thought it was. So I'd made an assumption at some point we'd changed the model, and I applied that change and it was slightly different. It could have been a theory issue. So what this chart is showing is something that can happen with like asymptotes. When you get close to the answer, you never actually reach there, but you get close. So it could have been something to do with that, but it wasn't. It was a code problem. And Chris was talking about kind of software engineering. I went back, I did it in a more software engineering kind of type, lots of different use cases for debugging, simplify, did a lot of unit tests to prevent things from for the future. And basically my learnings here was that it's all the same, all the same as for the first error or failure that was happening. Made my processes better, so learning from that thing. And then the feeling of whether it was a code problem or assumptions problem was different, which is strange for me. I didn't really understand that. And then a personal thing, being alone for a while is good working on a problem. Being alone for too long working on a problem is bad. So there's kind of a thing about working. And then the last thing I just wanted to share. So I need to watch out for this thought progression that I have, and I think I've seen in some other people as well, so this might be helpful. But I can very quickly start from identifying something that's not working as intended or as expected, and then sitting on it and mulling over it for a while, and then it suddenly turns into, oh, I am a failure, everything has failed, I am rubbish. So I need to watch out for that thought progression because it's not true. So great, thanks very much, and I'll stop sharing.